math has been driving you crazy, or if you're finally admitting you're lazy and your test grades have been dropping, it's time to get your arrows popping. Hello. How's everybody doing today? It is Mr. Witt with Fort Bend Tutoring, and today we will be dealing with the Algebra 1 end of course second semester final exam review. That's right, part two. So we already have Angry Hermit in the chat. How's it going, Angry Hermit? Good to see you this Saturday. Oh yeah, and I have some good problems for you guys. Okay, so there's a lot of problems that we're gonna go through today. Last time we were able to go through 30 problems. We have T High in the house. What's going on? How's it going there, T Hay? Good of you to join us today. We have Charmaine in the house. Let's go ahead and show some people the love here in the chat. Go ahead and get that chat going. Charmaine's here. Good morning, Mr. Witt, says Charmaine. There we go. All right, I got my orange juice ready. No pulp. So it should be a good session today, guys. Arian is in the house. What's going on, Arian? Glad of you to join us today. Good stuff. Yeah. We're going to have fun today. And just a reminder, Algebra 1, guys, this is going to be for the high schoolers and the middle schoolers as well as the adults that are trying to strengthen their algebraic foundation. That's important for those of you, especially those of you getting early in your math careers, and also entering into college this summer, let's say, going into pre-cal, calculus, all those things. You want to have a strong algebra foundation, and this will help with that. And for you high schoolers and middle schoolers that are ending the school year, this will help you with your final exam. So we have My Black is Beautiful. 16 Brian says, Mr. Witt, you helped me pass my intermediate algebra with an A. That is awesome. That is great news. Well, congratulations on passing your class with an A. Man, just doing the doggone thing, aren't you, My Black is Beautiful? That's great, Brian. And we have Lewis in the house. What's going on? How you doing? Glad you could join us. And just if you guys can make sure that you are subscribed to the YouTube channel Fort Bend Tutoring. Also share the stream with your people on your social media platforms there. Also keep in mind that we are going to be bringing you live final exam reviews for the next couple of weeks. And and then we'll go back to some just random math concepts from there. And that's what we're going to be doing. Yeah, that's what's got. That's what's going on. Yeah. Also, make sure that you're clicking the bell icon. That helps you get notified when we're going live with new content, as well as when we post new content on the channel. Yeah. So you know what? Here we go. Let's go ahead and get this thing started here. Know you guys are ready to get your math on today. That's right, with Mr. Witt in Fort Bend Tutoring. So here we go, guys. So in problem number 31, picking up from the last problem we left off on part 1, it says, given the function f of x equals negative x squared plus 8x plus 9, state whether the vertex represents a maximum or minimum point for the function. That's what they want. That's what they want to know. Well, what you should be aware of is that this is a quadratic equation and it's in standard form. So if we were looking at this problem here, let's go ahead and get my color black, that looking at this problem that we have it in the form of f of x equals to ax squared plus bx plus c. And what you need to know is that as long as this a value is positive, then the parabola will point up and therefore you would have a minimum. All right, can I get my point going? I just want to show a little point right there. Just a little point. There we go. That's what I wanted. That if you have a parabola, because this is the parabolic shape for the quadratic equation, that your parabola would point upward. However, if the a value is negative, then the parabola points downward and your vertex is going to be at the top of the graph. So in this case, because we have f of x equals to negative x squared plus 8x plus 9, we have a parabola that points downward. Therefore, our vertex would represent a maximum value. Good stuff. My Black is beautiful. You take care. Thanks for chiming in and letting us know how well you did on your intermediate algebra. Take care. Thank you so much. So here we're looking at our vertex being a maximum. And this is the answer to part A of problem number 31. So let's go ahead and red box it. That's right. That is what's going on. We have a maximum value at the vertex because we have a negative a value. A negative a value is what I was trying to say. That's right. So there is another form of the quadratic equation that you should be aware of, and it's called vertex form, but the same rule applies. And let me show you what that looks like. It'll look like y equals to a times x minus h squared plus k. This is the vertex form of a quadratic equation. And once again, that a value is what will help you determine whether or not the graph will point upward or downward. Bottom line, if it points up, you'll end up with a minimum value for the vertex. And if it points down, you'll end up with a maximum value for the vertex. Amen, amen. All right. That's part A of problem number 31. Let's look at part B. There we go. So we have the same problem. Yeah, it's problem number 31 again. However, with this f of x equals to negative x squared plus 8x plus 9, this time they want us to rewrite f of x in vertex form. See, I just showed you that vertex form was equal to y equals to a times, oh, that's an ugly a. It's an ugly a. All right, a times x minus h squared plus k. All right, so this is what we will call our vertex form, and this is supposed to be an h, and we'll see if this left hand of mine, there we go, can draw a better h. There we go. So we want to be able to take the given function and rewrite it in this form, and they're telling us that we need to do that by completing the square. So let's make that happen, guys. Let us start off with our given function, negative x squared plus 8x plus 9, and we are going to complete the square with this function in order to put it into vertex form. So our first step, guys, is going to be to factor out that negative. We want the x squared term to be a positive 1x squared. Currently it is not. Currently we have negative 1x squared, right? So we're going to start off by factoring out a negative out of the first two terms. That'll allow us to rewrite this as x squared minus 8x. We'll put a blank inside the parentheses here, plus 9, and put another blank right there. Okay, so with that said, our next step in completing the square is going to be to take half of the middle term's coefficient, which in this case is negative 8, and half of that value is going to be negative 4. All right, I know my 4 looks ugly, so I'm going to fix it. I'm aware. There we go. That's a better 4. Okay. That 4 is on fire. So we'll have negative 4, and we'll then square this value. And negative 4 squared gives us 16. What's going on, Tony? So that now that we have that, we'll have negative 4 squared. That gives you a positive 16 here. But you need to keep in mind that this value, the true value of this 16 that we place inside the parentheses, is 16 times negative 1. So 16 times negative 1 gives us negative 16, but we need to offset this to keep the equation balanced. So since we can multiply 16 times negative 1 to get negative 16, in order to keep our equation balanced, being as though we're only working on the right side of the equal sign, we'll need the opposite of that value. So the 16 times the negative 1 gives you negative 16, and the opposite of that is positive 16. And this is what goes in the blank here on the outside. Oh, yes. From there, we're going to be able to factor. So we're going to write this as f of x equals, we'll bring down that GCF of that negative 1 that we factored out earlier, and the factorization of our perfect square trinomial will always be your variable and whatever half of the middle term's coefficient was. And half of our middle term's coefficient is negative 4. So just bring that value straight down. In other words, that negative 4 that we have there, just bring that down. That's all you got to do. And just slap a square sign on there. And then we know that 9 and 16 combined will give you 25. So the answer here is f of x equals negative quantity of x minus 4 squared plus 25. This is your equation in vertex form. There it is. Yeah. So this is the answer. We're going to red box this. That's what we're going to do. But you know what? I think I may need this on the next page, so we're going to copy it first. That's what we're going to do. We're going to copy that. Then we're going to put it in the red box. So the answer for part B, guys, the vertex form of our quadratic equation is f of x equals to the opposite of x minus 4 squared plus 25. Done and done. And this was 31B. Let's see where they're going to take us from here. Well, in part C of 31, we had a three-parter to begin the final exam review. Thank you. They want us to find the vertex of the given function. Well, getting familiar with the vertex form, which is once again that y equals a times x minus h squared plus k, the vertex form is good in order to find the vertex because the vertex is the value hk. It's the ordered pair hk, where h is the x value of the vertex and k is the y value of the vertex. So we already have our equation written in vertex form. Remember, it's right here. Yeah. We already know that f of x equals to the opposite of the quantity x minus 4 squared plus 25. So in order to find the vertex from this, all you got to do is just find the opposite value of what's inside the parentheses. So the opposite of negative 4 is positive 4. And then our k value here is the 25. And there is the vertex of this parabola. Done and done. Thank you. I'm here all week. Yeah, I'll be, doing math problems all week long. Thank you. That's what I do. So yeah, that's it. 31C, guys. 31C. Done. That's right. What's going on, Kaylee? Going on. Kaylee's in the house, guys. Say hello to Kaylee. There you go. And we're on to our next problem, guys. We are on to our next problem. That was problem number 31, and now we're on problem number 32. With problem number 32, it says, what are the x-intercepts of the parabola? What are the x-intercepts of the parabola? Well, we have our parabolic shape here, our graph, right? And when they're asking you for the x-intercepts, when they're asking you for the zeros of a function, they're basically wanting to know where the graph touches the x-axis, right? So in our problem here, our x-intercepts can be found wherever the graph touches the x-axis, keeping in mind that the x-axis is this horizontal line here, okay, whereas the y-axis is the vertical line here. We want to know where the graph is touching the x-axis. So just to point this out, we have a intersection here and here, okay? So that means that our x-intercepts, the first one here, is going to be at -5, 0. All right. That's going to be where our first one is here. All right, looking at that from left to right, our first point right here, that's -5, 0. The second point will be found at -1, 0. Angry Hermit is correct with her answers. Very good, Angry Hermit. You're absolutely correct. Angry Hermit says that looks like -1 and -5, but I can't see it very well. Sorry about that. I understand. That's why I'm here to clarify, Angry Hermit. But our answers here are -5, 0 and -1, 0. So depending on the way the author writes the standardized test, guys, you may get away with just saying that the values of the x-intercepts are -5 and -1. But most of them in mathematics, they'll want you to give them an ordered pair as a result. So we'll give it to them as -5, 0. The point -5, 0 is the x-intercept, as well as the other point is -1, 0. But we are aware that sometimes they'll just have you, let me go ahead and change this ink up. Let me change the ink up for this one. Sometimes they'll have you write the answer as x equals to -5 and -1. Okay, so it's very well that they just may have you write down the x values where the x-intercepts are occurring, but then most of the time, okay, they'll have you write it as an ordered pair. So it depends on the author, it depends on your teacher, it depends on who created your final exam, all right? But just be aware that the answer could be written either way, depending on the author of the test. Okay, so that's problem number 32, guys, and we're moving along in these math problems today. That's exactly what we're doing. So we have problem number 33, guys. And in problem number 33, it says which property would be used first to simplify the expression 2 times the quantity of x plus 5y plus 1 minus 4 times the quantity of 3x minus y minus 2. There we go. So here is the deal. Tony's already putting in those requests. So either that's Tony or Noah trying to deviate from what we have here. All right. Tony, you need to just go ahead and buckle down, man, and get a private tutorial with me. All right. Then you can ask me all the questions that you like during that tutorial session. Trying to raid my party over here, Tony or Noah. Okay. So then Lewis says, is there a way to move the chat display to the right corner so that it won't block your notes instead of removing it? Let's see here. Maybe, Lewis, let's see. Let's see if we could do that. Lower right, lower left. Nah. No, doesn't look like it. Not in the version of this Wirecast play that I'm using right now. Yeah. So, guys, the first step that you would want to use, the first property that would help us in this particular expression as far as simplifying it, is going to be my favorite property in the world. That's right, Peggy. It is the distributive property. We're going to be going with C as our answer. And, of course, we're going to red box it. It needs to be the distributive property. That's right, Kaylee. The popping them arrows property. Absolutely. We're going to be popping those arrows. Good stuff. All right. So Lewis, at first I didn't even have the chat on here at all. So this is an improvement, believe it or not. All right. But yeah, moving it up. Yeah. That's about the best I can do for right now. But anyway, we got number 33, and it is distributive property, and Peggy has the answer right. Very good, Peggy. Peggy is holding it down, coming in here on fire with the correct answers. Good job, guys. So out of all of those properties that were listed, the one that we needed to simplify that expression first was the distributive property, my favorite math property in the world. Interesting that was the answer to that problem, right? Maybe a little inside bias. We have problem number 34. It says solve the following. And in this problem, guys, we have 2w plus 14 divided by 4w plus 6 equals 6/8. And there we go. Your sons, too. Yeah, there you go. And what we're going to do, we have a proportion in play, guys. We have a fraction set equal to another fraction. And when you have a situation like this, you can use the extremes means method in order to solve the equation, in order to solve the proportion. You can just very well get your arrows popping. That's exactly what you could do. And we'll end up multiplying 8 times the quantity of 2w. Oh, that's supposed to be a w, guys. There we go. That's a little better w. All right. And this equals to 4w plus 6 times 6. And we'll write it as 6 times the quantity of 4w plus 6. There we go. So we can set it up that way. Absolutely. From there, we will be getting our arrows popping. There we go. I didn't really give that much justice. Let me say it again. Let's go ahead and get our arrows popping. That's what I meant to say. Kaylee says, wow, I didn't know that. Look at Kaylee still learning stuff. I thought you knew everything already, Kaylee. Man, you still learning stuff. We have 8 times 2w is going to be 16w. We have 8 times 14. I don't know what that is. No, we're going to figure that out. That's 32 because it's going to be just 112. There you go. I didn't have it, guys. I didn't know. I had to figure it out. Then we're going to be multiplying 6 times 4w to give you 24w. And then 6 times 6, pick up the sticks. That's going to give you 36, right? There you go. That's right. Kayla says she's learning new stuff every day. Way to go, Kayla. Give you a reason to come back, right? So now we have that 16w plus 112 equals 24w plus 36. We were going to now isolate the terms with the variable w, right? So let's do that by subtracting 16w to both sides of the equal sign, guys. From there, we can bring down the 112. Then the 24W minus 16W gives you 8W. Oh, that's supposed to be a W. There we go. That's a better one. Plus 36, okay? And then Tony already knows to get those arrows popping. That's right. Lewis has his answer already. Kaylee has her smiley face going. We're going to be subtracting 36 to both sides of the equal sign here, guys. The 36 on the right will cancel out the 36 taken from the 112 on the left side of the equal sign. I don't know what that is. We're going to figure it out. That's a 0. That's a 12. That's going to give you a 6. That's 76. Is it 76? I think it's 76 according to Lewis's answer. I'm trying to get a decent 8 for us. There we go. Then we're going to be dividing both sides by W, guys. All right. So divide both sides by W. You'll end up with the following here. Okay. So we have the 76/8. We're going to be reducing this. Okay. Both of these values can be reduced by 4. Let's go ahead and rewrite it first. All right. So we got our W equals to 76/8. Oh, that's the ugliest 8 ever. Let's reduce both of these values by 4. Okay. And reducing both of these values by 4, guys, we'll end up with 19 halves, just as Lewis predicted. Very good, Lewis, with the answer for W. That's right. Done and done here. Okay. We have a red box around our answer, guys. And there you go. Yeah. That's problem number 34. We have solved the linear equation. We have solved the proportion. And we used the extremes means in order to solve it, guys. We used the cross multiplication application to solve the problem. And now we're moving on to our next problem, which is problem number 35. Yes, it is. Problem number 35, guys. It says to find the perimeter of the figure. Find the perimeter of the figure. And this figure, guys, the figure, because of our right angles here, because we know that the opposite sides are equivalent to one another, this has to be a rectangle. It's a rectangle, guys. And it's good to know what shape you're dealing with because that'll help you find the perimeter. Yeah, it is. And just so you know, okay, the perimeter formula is that supposed to be a P, Mr. Witt? Mr. Witt, was that supposed to be a P? That's the perimeter equals to 2 times the length plus 2 times the width. There we go. The formula for a rectangle. There you go, guys. There you go. The formula for the perimeter of a rectangle is P equals to 2L plus 2W. In other words, 2 times the length plus 2 times the width. So let's go ahead and just label this. Let's say that our length is the 9K minus 10, where our width would be the 5K plus 2. And then we will plug this information in to find out what the perimeter will be. So we know that, according to the formula, that the perimeter is equivalent to 2 times our length, which is in this case 9K minus 10, plus 2 times our width, which in this case is 5K plus 2. Once we have our setup here, we can go ahead and get our arrows popping, Peggy, so that we can go ahead and combine our like terms after we distribute, right? And therefore simplify this expression for the perimeter. So 2 times 9K is going to give us 18K. We have 2 times negative 10. That gives me negative 20, right? Then multiplying the second set of parentheses by 2, we'll have 2 times 5K. That gives me 10K. I'll have 2 times 2. That gives me 4. And then from here, we're going to go ahead and combine our like terms. We know that the perimeter is going to be our result here. We have 18K plus 10K gives us 28K, guys. And we also have negative 20 plus 4. Negative 20 plus 4 gives you negative 16. And we will red box our answer. Done and done, guys. Yeah, that's what's up. Problem number 35. In a red box where they had us finding the perimeter of the figure. So we couldn't give them an exact value. We couldn't evaluate this because we didn't have enough information to do that. But we were able to simplify the algebraic expression based on the fact that we knew that the perimeter of the figure had to be 2 times the length plus 2 times the width because we were dealing with a rectangle. Oh, yeah. That's what's up. That was problem number 35, guys. And now we're on to problem number 36. In number 36, we want to simplify the algebraic equation. We have the quantity of negative 4/3 a plus 1/6 a, minus 1/6 a plus 2 plus the quantity 1/2 a minus 5/6 a minus 6. That's what we're working with, guys. So, thanks, Lewis, for it being correct, for go ahead and backing me up on that, Lewis. So, in this particular problem for number 36, guys, we want to combine our like terms within the parentheses first. And combining your like terms within the parentheses, those a terms in both sets of parentheses, the only way we'll be able to combine those is if we go ahead and get a common denominator for those fractions within. So the common denominator for 3 and 6 in the first set of parentheses is 6. So I'm going to go ahead and set up my problem here by showing that I have the opposite. I have the denominator of 6 here. I got my variable, right? All right, I'm just setting my framework, as I call it. Knowing that I had to multiply 3 twice in order to get 6, I need to multiply the numerator by 2 as well. So 4 times 2 gives me an equivalent fraction, equivalent ratio, that is 8/6, negative 8/6a for that first term. Then we already had the common denominator that we needed for the second term's fraction, coefficient. So we'll keep that as negative 1/6a. Then, in the second set of parentheses, the common denominator for 2 and 6 is also 6. So that means that we'll go ahead and set up our framework with denominators of 6. All right, don't forget our variable there. Let me get that variable in a better spot. All right, get the variable in a better spot. All right, for the people, for Lewis. All right, for Tony and Noah. We have 2 being multiplied 3 times in order to give us the denominator of 6. So the numerator needs to be multiplied by 3 as well. So 1 times 3 gives you 3/6a. We already have our common denominator of 6 for that second term's coefficient. So just bring down the 5. Just bring down the 5. Or you can say 6 times 1 is 6. Therefore, 5 times 1 is 5. And now we have everything rewritten to where we can combine our like terms within the parentheses. Notice that we're working within the parentheses first, combining our like terms. Now we'll end up with negative 8/6 minus 1/6 to give us negative 9/6 a plus 2 plus, within the second set of parentheses, we'll have 3/6 minus 5/6. That gives you negative 2/6 a minus 6. All right, so this is what we have thus far, guys. All right, from here, we'll be combining our like terms. You can actually drop these parentheses at this point, and combining our like terms, you'll have negative 9/6 a and another negative, and not another, but we also have negative 2/6a. That'll give you negative 11/6a when you combine those like terms. Remember that like terms, when you have the same sign, you add the numerators together. You add them when you have like signs, whereas when you have unlike signs, that's when you subtract. Now, combining your 2 and negative 6, because they have unlike signs, you will subtract them. Keep the sign of the biggest value. You'll end up with negative 4. There you go. You'll keep the sign of the biggest digit, I should say. All right, not the biggest value. So this gives you negative 11/6a minus 4. That's the answer. That is the answer. Very good, very good, very good. Lewis has his answer correct as well. And this deserves a red box, just like that, guys. That is how we go about solving problem number 36 with Lewis with his correct answer in play. Very good, Lewis. Lewis is on fire today, guys. Lewis is showing us why he deserves that moderator status. Very good, Lewis in the house. All right, guys, I wanted to remind you guys that we would like you to get some personalized tutorials from me, Mr. Witt, and Fort Bend Tutoring. So if you ever need a one-on-one tutorial, you can catch me online, guys. Go to tutormemath.net. The website address is right there, and you can get some one-on-one tutorials with me, Mr. Witt. That's right. You can hire me to be your private tutor. All right, there you go. So keep that in mind, ladies and gentlemen. You can find out more information about that at tutormemath.net. Amen, amen. Let's move on to our next problem, which is problem number 37. Problem number 37 is in the house. They want us to find x, guys, when f of x equals -6. Well, we need to realize, first and foremost, that f of x is equivalent to the variable y. All right. So they're saying to find out the x value when the y value equals to -6. So according to our function of f of x here, according to this graph, we have a value of y being -6 right here at this point down here. Okay, so here, tell me if you can check this out, Angry Hermit, if you can see this on your screen. That down here, this value on the y-axis is -6, and that's lined up with our point that we have, okay, at the bottom there. So we want to find out what x value corresponds with that y value of -6. So in this particular problem, this point here, let's go ahead and label that point, is going to be at 1, -6. So the ordered pair for that point at the bottom there is 1, -6. So therefore, the answer to this problem is x equals 1. There you go. And that is the answer to this problem right here, because they wanted to know what x value generates a y value of -6. So the answer to this is x equals to 1. And Lewis is on fire with the links in the chat, hooking you guys up with that link for the domain. All right, for the domain. Thank you so much, Lewis. Good deal. From here, they're asking us to identify the domain and the range for problem number 38. We're using the same graph. They want to know the domain and the range of our function here. And when you're dealing with the domain of a function, guys, they simply want to know what can the x values be. So you're going to go from the least x value, the lowest x value, all the way up to the highest x value. And notice that I'm moving horizontally because the x-axis is this horizontal line here. So you want to go from the smallest, x value along the x-axis to the highest x value along the x-axis. And because all of our points are connected here, then you're going to have everything being continuous within it. All right, so you'll have an infinite amount of x values between your lowest x value and the highest x value. So due to that, we'll be writing our answer a couple of ways depending on your text, depending on the author. One way to do this, all right, we're going to do it as a compound inequality first. You'll say that your values of x are going to be less than or equal to our highest x value, which is 7, as well as greater than or equal to your lowest x value, which is going to be -5. So you can express the domain as a compound inequality in this format here, where we're saying that x is greater than or equal to -5, as well as less than or equal to 7, and everything in between. Exactly. Shafiq is in the house. What's going on, Shafiq? How you doing, sir? And also, we can write this as interval notation. So depending on your teacher, depending on your class, you may have been shown interval notation, and the way you would write that is you'll say that it is a bracket, -5 to 7, close bracket. There you go. Yeah. How you doing, Shafiq? So yeah, so that is two ways. Those are two ways to express the domain for your Algebra 1 course. Good stuff. Thank you so much, Shafiq, for watching the videos. I really appreciate that. Let's go ahead and give you some love here. Let everybody see what you're looking like. There you go. So Shafiq is in the house, and I am saying, how you doing, Shafiq? Thank you for joining us. I appreciate you coming by. So Shafiq says, I watch your videos so much. Thank you so much. All right, I appreciate that because I put a lot of work in these videos. It would be nice if somebody watched them, Shafiq. All right, and Shafiq says that they help him so much. That is awesome, Shafiq. Thank you so much for being a supporter of Fort Bend Tutoring in our videos. I really appreciate that. Let's move along, guys, because the next thing we're going to do is answer the question for the range of f of x. The range, guys, is simply the lowest value of y to the highest value of y. So as we're checking out our graph here for f of x, we start at the bottom at the lowest y value that you can find on the graph. And in this case, that lowest y value is going to be -6. -6 is the lowest value, whereas the highest value on the y-axis in the graph is the point here. We'll go ahead and identify this point. I'm going to go ahead and identify this point for you guys. This largest point, the highest point here, is going to be at -3, 5. The highest point on that graph is at negative 3, 5. So therefore, we want to go from the bottom y value, the lowest y value, to the highest y value. So in this case, we'll say that we have negative, hold on for a second, guys. I went ahead and messed up my doggone stylus. Let me go ahead and fix this real quick, guys. Once again, live streaming with the technical difficulties. There we go. All right. So the lowest y value here is going to be, what's going on, Treasure Ghost, is that we have negative 6. This is going to be y, which will be less than or equal to our highest value, which is going to be 5. So as a compound inequality, we'll have negative 6 is less than or equal to y, which is less than or equal to 5 as your range. And in interval notation, you can write it as bracket negative 6 to 5, close bracket, as the range of our function. Let's go ahead and red box this stuff here. So depending on the author, depending on your exact class for Algebra 1, because you could be in an AP class or pre-AP class for Algebra 1. And if you're in a pre-AP class, you may have been, you guys may have gone over interval notation. So as a compound inequality, you can write it as negative 5 is less than or equal to x is less than or equal to 7 as far as the domain is concerned. All right. Or you can write it in interval notation as well. Same thing goes with the range. And that completes problem numbers 37 and 38, guys. And we are moving on as Treasure Ghost joins the party. What it do, Treasure Ghost? That's right. All right. Peggy says, can I repeat that problem? No problem. All right, let's go ahead and recap for Peggy, guys. Let me go ahead and move the chat out of the way again. Peggy wants to know how to determine the domain and range of the function. The bottom line is, it's when it comes to the domain, Peggy, they want you to tell them what x can be. All of our points within this graph have an x and a y value. So, for instance, the point at the bottom here is 1, negative 6 as an ordered pair. The x value within that is 1. The y value within that is negative 6. For the domain, they want you to tell them what the lowest, the smallest x value is all the way up to the highest x value, the largest x value. All right, good deal. Peg is preparing for her Texas exam, her thesis exam. About to take her TEKS to become a teacher. Awesome. Good stuff, Peggy. Good luck to you. So when they're asking you for the domain, they want to know the lowest x value to the highest x value. Our lowest x value on this graph, Peggy, is negative 5. Because this point here is at negative 5, negative 1. So your lowest x value is negative 5. Whereas the point here on the right is going to be 7, 0. It's at 7, 0. If I could draw a 0 here. There we go. So the lowest x value is negative 5, whereas the highest x value is positive 7. So that's what we're expressing here for our answer for the domain. We're saying that the lowest x value is negative 5 all the way up to the highest x value in that function, which is positive 7. And that is your domain. Your domain can be continuous as we have it in this problem because everything's connected. Or it could be a situation where you have just points on the graph, and in that case you have a discrete set of values for your domain, and in that case you would just list all the x values separately in that case, Peggy. But because everything is continuous between negative 5 and 7, you can go ahead and express it as a compound inequality, or you can express it in interval notation. As we move on to our range, they're looking for the lowest value on the graph to the highest value on the graph. So the lowest value for y is negative 6 all the way up to the highest value on the graph, which is positive 5. And this is why we're expressing our values here as a compound inequality from negative 6 all the way up to positive 5. And notice that we're focusing on the y variable because we're referring to the range, which is going up and down, whereas the domain moves from left to right. Okay. In interval notation, which is another way to write the answer, we can express this as negative 6 up to positive 5. Include those brackets because we're including those values within the range. All right, so hopefully that explanation helped you out. You can check out more information about the domain and range as Lewis has already pointed out with our link for finding the domain of a function. Check out that video, Peggy. It'll give you some more explanation about the domain, and you would want to know that for that TEKS exam that you'll need to be taking soon. All right, good stuff. Ask and you shall receive. Good stuff. Thanks for asking, Peggy. Good stuff, because as you already know, you want your students to ask questions. That's how they get more out of you. So good stuff displaying that for everybody. You ask questions of me, you get more explanation, guys. It's the way it works. Problem number 39, they're asking us to solve this equation, guys. We have x plus 4 divided by 2 equals to 4x minus 6. The first thing I want to do is I want to eliminate these fractions here, all right, because they just bother me. All right, I don't want to do the problem with the fractions, so we're going to get over this. So Treasure Ghost, he has a problem in effect right now. All right, let's see how Treasure Ghost got this result, guys. Well, we can start out by multiplying each and every term by the common denominator of the entire equation. So I'm going to start out just as Treasure Ghost did by multiplying each and every term by our LCD of 2. So that's what I'll be doing first. Multiplying each and every term by the LCD, which is 2. What happens with our first term on the left side of the equal sign is that the 2's will cancel out. So I'll be able to bring down x plus 4 on the right side. 2 times 4x is 8x. Negative 2 times 6 is negative 12. From here, we'll be combining all of our terms that have an x in them. I want to isolate all the terms with a variable. So I'll be subtracting x to both sides of the equal sign, which uses the subtraction property of equality. From here, we'll be bringing down the number 4. 8x minus x is 7x. Minus 12, we'll be then adding 12 to both sides of the equal sign. So you'll end up with 16 equals 7x. From here, we'll be using the division principle of equality and dividing both sides by 7. So once we do that, we end up with a result that x equals to 16/7. It's a result that Treasure Ghost already had, guys. That's right. Way to go, Treasure Ghost. Lewis has already given you a thumbs up on that. So we end up with 16/7 as our result, and I hate that 16/7, so we're going to fix it. I want to make mine pretty like Treasure Ghost did, if I can get the right ink here. There we go. That's a better 16/7, right? There you go. That looks better. We'll go ahead and red box that. How about that, Treasure Ghost? There we have it, guys. That was problem number 39. Done and done. Good stuff, guys. Y'all just flew through that problem. All right, good deal. Let's look at problem number 40 then. See how that looks. Here, we want to state whether the sequence is arithmetic or geometric. Then write the explicit form of the sequence. How you like that for problem number 40, guys? So the way you can tell whether or not you're dealing with an arithmetic sequence or a geometric sequence, guys, is whether or not they're adding a value each time. That lets you know that you're dealing with an arithmetic sequence, or if they're multiplying by the same value each time. All right, good deal. So Magnetile says, I'm just here because your voice is amazing. Love all your videos. Thank you so much for the compliment about my voice. Thank you so much. My voice loves you too. Then Treasure Ghost says that 100% it is arithmetic. All right, well, what can you guys determine that they're adding each time? All right, because we already have been told by Treasure Ghost that we're dealing with an arithmetic series, an arithmetic sequence, and he is correct. But the reason I want to verify this is that we'll need to know how much they're adding by each time in order to end up with the explicit form of our arithmetic sequence. So let me go ahead, guys, and give you the formula for the explicit form of an arithmetic sequence. Let me go ahead and do you a favor here. You'll have a of n equals to a1 plus d times n minus 1. So this is going to be the Lewis says I'm the Soul Train man. I am not Don Cornelius. But that is funny, Lewis. Good deal. Y'all always ripping me about my voice. Y'all know y'all wrong for that, right? So anyway, The D value in this, guys, is going to be the difference between each term. That's what the D represents. Whereas the A1 value is going to be the first term in the sequence. Okay. And AN already has his, what is AN? AN, what you doing? Is that the answer? Is that what you're working with? Let me go ahead and see. Or AN, you give me a problem to solve. Seems like you might be giving me a problem to solve, AN. But we are going to be focused on solving this problem right here first. Okay. So in order to get the explicit form. So first of all, guys, let's go ahead and get things straightened out here. First of all, we definitely want to acknowledge the fact that we are dealing with an arithmetic sequence. So this sequence is an arithmetic sequence. And the reason for that, guys, is because they are adding 4 each time to get to the next value, right? Or subtracting 4, adding a negative 4. Sorry. They're adding negative 4 each time to get to the next term. So that's why it's an arithmetic sequence. So our D value is negative 4. That's what they're adding each time to get to the next term. Whereas your first term is 6. So utilizing the D value of negative 6 and using the first term as 6, we can find out our explicit form. Treasure Ghost says, you don't give me credit for determining whether. No. Treasure Ghost, of course you did. I already said that you came up with the correct answer. Come on, Treasure Ghost. Well, Treasure Ghost. All right, let me rephrase that, guys. We did not come up with the arithmetic solution. Treasure Ghost did. All right, there you go, Treasure Ghost. All love, sir. All love. So now, plugging in these values into our explicit form, we can solve for the explicit form of the sequence. So A of n in this case would equal to 6 plus negative 4 times the quantity of n minus 1. From here, you want to distribute, get your arrows popping, and then combine your like terms. So that means that we'll have A of n equals to 6. Negative 4 times n is negative 4n, and then negative 4 times negative 1 gives you positive 4. Combining your like terms, you'll end up with a result that is negative 4n plus 10, and this is the explicit form of our sequence, the arithmetic sequence that Treasure Ghost highlighted. Amen, amen. Getting fussed at by Treasure Ghost, guys. There we go. So that's how you do it. That's how you do it. So here we have problem number 40. It's already solved. They wanted us to find out whether or not the sequence was going to be arithmetic or geometric. Remember, guys, the difference between the two is that for the arithmetic sequence, they're adding a value each time, whether that value be positive or negative. It depends on the problem. Or it could be geometric because they're multiplying by the same value each time to get the next term, okay? So we already know that this sequence, this explicit form will work because if we wanted the first term, for instance, we would substitute all the n's with the number 1, and negative 4 times 1 would give you negative 4, and then negative 4 plus 10 is positive 6. That works, right? That works. Let's see if we plugged in, let's see if we've got the second term. Replace all the n's with the number 2. We would have negative 4 times 2, which is negative 8, and negative 8 plus 10 gives you positive 2. There you go. All right, that's it. So Ann has a problem, guys. Ann, you want me to solve this problem? Why are you trying to stress me today? Let me go ahead and solve this problem for Ann, guys. All right, so Ann has a problem. Let's go ahead and let's hook up Ann since he dropped by today. He didn't have to drop by, but he did. So let's go ahead and see what Ann's talking about, guys, with his problem. Ann's problem, let's call it A1 for Ann's problem. We have 16x plus 9 equals to 24. Okay? We have 16x plus 9 equals 24. And with this problem, Ann, you want to isolate the term with the variable first. So we're going to subtract 9 on both sides. Subtracting 9 on both sides, you'll end up with 16x equals 15. Then you'll divide both sides by 16. And you would simplify this as much as possible, and it already is. So the answer is 15/16 and done. How you like that? All right. There you go. 15/16. Treasure Ghost already has it for you, and Lewis already has it for you, and we have just hooked you up with your problem live. How you like that? The chat is awesome with the assistance they're providing today. How about that? And can't get it any better than that, sir. All right. So now that we have hooked up Ann, let's get back on track. with problem number 41, where they want us to state whether this sequence is arithmetic or geometric, then write the explicit form of the sequence. We have 3, 6, 12, 24, 48 for the first few terms of the sequence. That's right. Lewis says the chat is popping. Absolutely. Angry Herman has a link to help out Ann. Absolutely. Peggy says, can I video record this? Absolutely, Peggy. You have permission to do that, but I will let you know that the video will be posted automatically when we're done today. Treasure Ghost says that this sequence is geometric. This sequence is geometric, guys. And the way we can confirm that, Treasure Ghost, is by letting everybody know what our value is that each term is being multiplied by each time. So let's go ahead and look at the form of the explicit form. So let's go ahead and give Treasure Ghost his credit first by saying that, yes, this is a geometric sequence. It's geometric because they are multiplying each term by the same value in order to get to the next term each time. That's how you know that you're dealing with a geometric sequence, because they are multiplying by the exact same value each time in order to generate the next problem. Treasure Ghost says 101 credit. No. You get an extra 10% on that one, Treasure Ghost. That's 110%, not 101%. All right. You don't get to control the rubric. You can only give the correct answer, sir. I'm in charge of how I'm grading this, and that's 110% credit for that one, Treasure Ghost. Get your life right. So now let's check out the explicit form, guys. The explicit form for a geometric sequence is a of n equals to a of 1 times the ratio, the amount that the value that's being multiplied each time, raised to the n minus 1. And we'll put that in parentheses for the people. There we go. All right, so that is going to be your explicit form. That's right. For the geometric sequence there. Lewis says we need a link. All right. Well, I could give you a link, but I haven't made a video on this yet. So I guess I need to get popping on doing the arithmetic and geometric sequence. I agree. I'll be working on that one, Lewis. So what we need to recognize first and foremost, guys, is that the first term in the sequence is the number 3, whereas the value that's being multiplied each time, that R value, is going to be the number 2. Notice that they are multiplying by 2 to get from one term to the next term. So in other words, 3 times 2 gave us 6, 6 times 2 gave us 12, 12 times 2 gave us 24, and so on. So in order to get our explicit form for this geometric sequence, we simply replace the A1 value with 3 and the R value with 2, and you have your explicit form of the sequence. So this is going to be A of n equals 3 times, let's go ahead and put a nice little, there we go, that's better. We'll say 3 times 2 raised to the n minus 1. You can put that in parentheses if you like. And there we have our explicit form of the sequence, this geometric sequence for problem number 41, guys. So here is our result in a red box. There we go. There we go. Good stuff. So the link has been shared, guys. There you go, by Treasure Ghost. Done and done. All right. That's problem number 41. Problem number 41, done and done. Okay. Well, let's move on to our next problem, guys. That was problem number 41. We just blasting through these problems today, guys. Blasting through the problems. Amen, amen. Seems like the chat is having fun with links. We have problem number 42. It says to state the number of real solutions from the following quadratic equation. X squared plus 10x minus 4 equals 2x minus 20. Peggy, this concept will come in handy for you. All right. So, guys, one way to determine the real solutions of a quadratic equation without solving the quadratic equation is to use the discriminant. All right. The discriminant can determine what type of answers you'll have and how many of those answers you'll have. All right. So what you want to do first and foremost is set this equal to 0. Set the equation equal to 0 first. And we'll do so, guys, by subtracting 2x to both sides of the equal sign. And if you'll allow me, I'm going to go ahead and add 20 to both sides of the equal sign as well. All right, so we're going to do this. We're going to do this two-step process in one step. All right, so we'll end up with x squared plus 8x plus 16 equals 0. And this is what we have so far. The discriminant, ladies and gentlemen, is going to be the value. The discriminant is, let's say that d is equal to b squared minus 4ac. And this is coming from the fact that during your standard form of a quadratic equation, you would have it written in the form of ax squared plus bx plus c equals 0. So what we'll be utilizing here are the coefficients of our quadratic equation right here. All right. So that being the case, Angry Hermit has a link there. Thank you, because I definitely have a video on the discriminant. Thank you very much, Angry Hermit, for providing that link there, guys. We can go ahead and plug in 8 for B, and we can also plug in 1 for A and 16 for C. Doing so, we'll go ahead and simplify this. 8 squared we already know is 64. Minus 4 times 1 times 16. Multiplying those values, you'll have 64 minus 64. So you end up with a result of 0. All right. We end up with a result of 0, multiplying that out. Anytime your discriminant is 0, guys, you'll end up with one real rational solution. So the answer to this problem is 1. The answer to this problem is 1. They said, how many real solutions from the following equation would you get? Now notice that we found the discriminant, yes, but we did not actually solve the quadratic equation. All we did was get our discriminant value, which is 0 in this case, and it told us, based on the fact that we ended up with a result of 0, that we would end up with one real rational solution. All right, and just to recap on what I'm looking for, guys, check this out. Once again, if you end up with a number, if you end up with 0 for the discriminant, then that means you'll end up with one real rational solution. However, if we ended up with a, let's say, a perfect square, all right, that's greater than 0. If we ended up with that, we would end up with two real rational solutions. If we ended up with a value that was greater than 0, all right, but not a perfect square, you would end up with two irrational solutions. And if your discriminant is less than 0, meaning it's a negative number, you'll end up with two complex solutions, two imaginary solutions. Okay, so that's what you would end up with depending on the discriminant. So once again, to get a full lesson on the discriminant, guys, go ahead and check out that link for finding the discriminant of a quadratic equation, as I go over many problems for you in that video. All right, but this answer is 1. Yeah. How many real solutions? 1. You get 1. There you go. And another hack for this problem would be to simply solve the equation, and you would end up with only one answer, which would be -4, I believe. Yeah, -4 is what you would end up with as the only solution that you would have for this equation. Amen, amen. All right, that's problem number 42. Problem number 42, guys. And as a reminder, please subscribe, guys, to Fort Bend Tutoring's YouTube channel. I would greatly appreciate that. Also, share the stream with your friends and family, especially on Facebook and Twitter and all that good stuff. And if you will, go ahead and click on that bell icon. That will help you to be notified when I go live with new content, or if I post new content on our YouTube channel. You'll get a notification if you click on that bell icon. And if you're able, please donate, as that helps us provide more free content to the world. That is right. So we're putting in some work. We need a little help from you guys every once in a while. So if you can donate by using the super chat or by using the link that you'll find in the description box, we will be great. Thanks, Lewis, for verifying that last answer was -4. Appreciate that, Lewis. So please subscribe to Fort Bend Tutoring and spread the word, guys. Appreciate that. Let's move on to our next problem. We have problem number 43, guys. Problem number 43, it says to completely factor the following quadratic equation. Completely factor the following quadratic equation. We have 6x squared plus 13x plus 6. And we are dealing with a quadratic equation where our a value is not 1. Well, in a situation like this, guys, I like to use the AC method, all right, in my version of it, okay? And what I do is I will go ahead and multiply the first and the last coefficients. In other words, I'm multiplying 6 times 6 to give me 36. And working with 36, guys, I want to be aware of all of the factors of 36. And that means I'm looking at 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And we're looking for 2 factors of 36, guys, that will add to give me 13. So which of these groups, which of these sets of factors would add to give me 13? Thank you, Angry Hermit, for the link for factoring quadratic trinomials. Part 2 is the one that we would want on this one. Good deal. Thank you, Angry Hermit. So here we have 2 factors of 36 that would add, according to that last term there, to give us 13, the middle term. And we would be needing the 4 and the 9, guys. So I would then open up 2 sets of parentheses from here. I'll need my variable x. I'll need 9 and 4. And the sign of the middle term will always be the sign of the middle term's coefficient. So since the 13 is positive, the 9 must be positive. And because we're adding to get 13, the 4 also needs to be positive. But we're not done, guys, because we had a leading coefficient of 6. Due to that, you're going to divide both of these factors by 6 and simplify. Simplifying the 9, 6, and the 4, 6, you'll end up with x plus 3 halves. And in the second set of parentheses, you'll have x plus 2/3. And any remaining denominators, guys, will go in front of your variable. Any remaining denominators will go in front of the variable. All right. So that's what you can look forward to, so that you end up with the final result. That is 2x plus 3 times 3x plus 2. And this is the complete factorization of problem number 43. Good job there, Lewis, handling your business, sir. Did you put your answer in a red box, Lewis? Because mine is in a red box, sir. All right, let's get that answer in a red box, Lewis. There you go, guys. That is factoring a quadratic trinomials where the first value is not 1. Thank you very much, Treasure Ghost. Treasure Ghost says, great job, Mr. Witt. Good deal. Give me that 2 T's on my last name, no there. Treasure Ghost, I need those 2 T's, not the 1 T. Lewis, you got some red ink. Stop holding out. Stop holding out, Lewis. All right. That was problem number 43 done, guys. Let me make sure I have my numbering correct. I do. Good deal. So we are now on problem number 44. You can put in parentheses after your answer, Lewis, or in brackets that it's indicating that it's in red ink. That's how you can red box it. All right. Problem number 44. I'm just tickling myself. We have, what is the solution set for the equation 2x squared minus 30 equals 98? Really, Angry Hermit? Why can't I get a WHITT? Let me go ahead and hook up myself over here since y'all being so mean to me right now. Let me go ahead and get a Mr. Witt in here on the chat since folks are hazing me for some reason. All right, there we go. Bam, Mr. Witt in the house. So, in order to solve problem number 44, guys, we are going to start by, and believe it or not, we're going to start actually by simplifying this. I've actually grown quite fond of simplifying my answers, simplifying my equations first is what I meant to say. All right. So I'm going to reduce everything by 2 first. That's what I'm going to go with. Okay, I'm going to reduce everything by 2 first because I want to simplify the equation. So let's start out by rewriting this. So we have 2x squared minus 30. This equals 98. We're going to be dividing each and every term by 2 first. All right. So instead of manipulating the equation first and doing all this other, nope. I just want to simplify it first because everything could be reduced by 2. So just to let you know, guys, that it's always okay to simplify by a number, but never a variable. All right. When you're simplifying an equation, you want to divide by a number, never a variable. All right. Because that's eliminating the solution. So that's why you don't want to do that. So that being the case, you'll have x squared minus 15 equals 39. Yeah. No, it's 49. Get my lie right. 49. There we go. Better. Another reason why I wanted to get those numbers smaller. Because I'm going to jack it up otherwise. So, dividing each and every term by 2, you end up with your equation rewritten as x squared minus 15 equals 49. From here, we'll be adding 15 to both sides of the equal sign. How about that? In adding both sides by 15, you'll end up with 64. So we have x squared equals 64, and Lewis and Treasure are now correct. Very good. We're going to be using the square root property in order to solve this problem at this point. So what you could do, because you could have factored it. All right, so you know what? I'm going to solve this 2 different ways, guys. I'm going to solve this 2 different ways. I think the first way I'm going to solve it is by factoring it. Let's subtract 64 to both sides. Let's do that. If we subtract 64 to both sides, okay, let's get a better 64. You'll end up with x squared minus 64 equals 0. And then from here, once you have that, you can then factor the difference of squares to get x plus 8 times x minus 8 equals 0. And then set each factor equal to 0 and solve for it. So you'll have x plus 8 equals 0, as well as x minus 8 equals 0, and then you'll solve for each equation. Solving for the first one, you'll find that x equals to negative 8. Solving for the second equation, you'll find that x equals to positive 8. All right. So as a solution set, all right, you can go forward from there. So you'll end up with completing the square won't help too much because you'll still end up with the square root property in the end, Lewis. It's not that you can't use it. It's just that it doesn't assist you any, really. So you'll have solutions negative 8 and 8 for this problem here. All right. And that's solving this by using the zero factor properties, solving this quadratic equation by factoring. Okay. So that was one way to solve that problem. But I told you guys I wanted to show you two different ways to continue this problem here. So let me go ahead and give you the other way. Give you the other way to solve it probably. All right. So you don't want no problems with me. All right, just saying, but except for this problem. There we go. Shout out to Chance the Rapper. We have x squared equals 64. That's what we got, guys. And so with this problem here, we are going to go ahead and use the square root property. That's what we're going to do. We're going to use the square root property. Got stuff on my screen. Let's go ahead and clear that out there. And taking the square root of both sides of the equal sign, we'll end up with, we have x, the absolute value of x, equals to 8. Because using the square root property, you have to guarantee that your result is positive. That radical sign there, that square root sign, is always asking for the principal root, aka the positive root. So in order to ensure that, you need to show that you have the absolute value of x as a result of taking the square root of x squared. And of course, the square root of 64 is 8. So now you have an absolute value equation to solve. And the absolute value is just the distance to 0. So where on the number line is a value that's 8 places away from 0? Well, you can have that at positive 8, of course. Or you can have this value at negative 8, because negative 8 is also 8 places away from 0. And you once again end up with your solution set. Oh, that's supposed to be a brace. There we go. Of negative 8 and 8. There we go. That's once again supposed to be a brace. Oh my God. Why? It's close enough. Thank you. Red box in it. That's right. Done and done. 2 different ways. So what did we show you guys? We showed you that according to the method that you use, you'll end up with the same result. This first method that I used, after I simplified the equation by dividing everything by 2, is I went ahead and I found out that the result could be factored due to this difference of squares that we have on the left side of the equal sign. All right, there you go. Nice. Okay. Yeah, I would not be using that discriminant because, oh, well, you know what? That is way too high, bro. I mean, you must be talking about the original equation. Yeah, because that's just ugly. That is way too ugly. Yeah, so, yeah, simplify it first, then find the discriminant that way, guys. Because that's just way too ugly. Way too high. Yeah, but anyway. Treasure Ghost says, quote from Mr. Witt, "You're absolutely correct, Lewis." We'll see about that. All right, so that concludes the 2 different ways of solving problem number 44, guys. All right, I use the square root property for that second method, right? First method, the zero factor property. What it do? We got problem number 45. That's what's going on right now. I see a whole lot of fractions. I'm irritated. Let's see how to best solve this problem. It says to solve the equation for x, guys. So we have 1/4 times the quantity of x minus 4 times x minus 2. Looks ugly. Equals to 1/7 times the quantity of 7x plus 14. Well, I think the first thing I want to do here is get my arrows popping inside of the parentheses by distributing that -4. That's what I want to do first. Yeah. I want to distribute this first. Thank you. So let's go ahead and bring down this 1/4 here. Times 8 minus 4x plus 8 within the parentheses equals to 1/7 times 7x plus 14. That's what I have going on. There you go. I'm going to then combine my like terms within the parentheses. So I'm going to have 1/4 times -4x plus 16 equals 1/7 times the quantity of 7x plus 14. That's what I got right there. There you go. Nice. All right. Angry Hermit says I had to get stuff done. See you later. Hey, thanks so much, Angry Hermit, for chiming in. I appreciate you. See you next week. Take care, Angry Hermit. Thank you for stopping by. Appreciate that. Let's go ahead and get that out of the way so we can continue the problem. Guys, multiplying from here, we'll distribute. Of course, we're getting our arrows popping on both sides of the equal sign. However, it's pretty cool because multiplying by 1/4 in this first set of parentheses, all you got to do is divide by 4. That's right. So the chat is telling Angry Hermit goodbye. That's right. So we have -4x divided by 4 gives you -x. We have 16 divided by 4. We have a positive 4 here. Then taking 1/7, distributing that into the second set of parentheses is the same as dividing by 7. So 7x divided by 7 is x. 14 divided by 7 is 2. There you go. And from here, guys, we're going to be adding x to both sides of the equal sign. That's exactly what we'll do. You'll have 4 equals 2x plus 2. And then subtract 2 to both sides. You'll end up with the following. You'll have 2 equals 2x. So if you divide both sides by 2, guys, does x equal to 1 is the question. Treasure Ghost got that. X equals 1. Very good, Treasure Ghost. That is what's up with the correct answer. That is right. There it is. X equals 1. Treasure Ghost had that answer. Let's go ahead and give him credit before he takes it, because that's what he does. Treasure Ghost in the house representing. That's exactly what he's doing. Let's go ahead and give him some love here. Let those witnesses recognize his glory. There it is, Treasure Ghost. You were in the house on that one. Problem number 46, guys. It says to solve the equation for x. Solve the equation for x. Here we go. We got a proportion, guys. What's up, Enzo? Enzo in the house. Lewis, your vision is blurry. Really? Why? You need to wear some glasses or it's not focused. All right. X equals no x? I don't know about that, bruh. You say your x is canceled out and that's a problem? Let me see what happened. I think you're down here at this point. And you have myopia too? Oh, y'all just freaking out over here. Hey, Lewis, Treasure Ghost. Here we added. Oh my God, Lewis is diabetic. Man, you better get your insulin going. You better get you some food in your system, Lewis. We can't have you checking out because you're diabetic, bruh. All right. They say I'm borderline diabetic. All right, so you got to eat better, man. Make sure that diet is on point. And get your checkups regularly. All right, so here we're going to be adding x to both sides of the equal sign. That's what we got going on. Yeah. All right. So on the left side, the x is canceled out, but x plus x is going to be 2x. All right. It's going to be 2x. So that's how we did not have those x's canceling out, just in case you guys wanted to verify about that. From there, we ended up with 2 equals to 2x, and then we divided both sides by 2 to get x equals to 1, as Treasure Ghost got. There we go. All right, so that's the recap on that previous problem. Let's look at this one right here. Let's keep Lewis in our prayers so that he can conquer that diabetes. All right. Hopefully get his body to be healthier. All right, good deal. We have problem number 46. It says solve the equation for x, guys. We have a fraction set equal to a fraction. You want to cross multiply. You want to get your arrows popping around here. That's what you want to do. So you can set this up as x times x minus 2 equals the quantity of x minus 2 times x plus 1. There you go. You got that x equals no x. I think you're playing games with me, Treasure Ghost. There's no way you got x equals to no x. All right. So that being the case, I think you joking with me. I know you joking with me, Treasure Ghost. So over here, after we do our extremes means method, guys, we're going to go ahead and multiply everything out here. I'm about to get my arrows popping while Treasure Ghost is over there playing games. There you go. So we end up with x times x is going to give us x squared. We have x times negative 2 is negative 2x. On the right side of the equal sign, you better believe I got my arrows popping over here because I got x times x, which is going to give us x squared. X times 1 is going to give me x. Negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. Round this piece. Don't play with me when it comes to multiplying binomials. I will kill these problems, right? So we're going to be bringing down the x squared here, minus the 2x. On the right side of the equal sign, I have x squared. All right, let's get that squared. The squared is ugly. Hold on. There we go. That square was going ahead and going crazy. We have, there's a solution. You got no solution for what? You got no, oh my goodness, guys. Y'all are killing me. Y'all got no solution for the previous problem? Let's see here. We got the negative 4x, boom, boom, boom. That gives you negative x there, boom. Yeah, you guys are incorrect on that one. Yeah, you're incorrect on that problem, guys. Let me help you out. On the left side of the equal sign, we have negative 4x within the parentheses. Okay, let's just focus on the x's, okay? If you focus on the x terms, you have negative 4x right here, right? Negative 4x right here. Multiplying 1/4 times negative 4x gives you negative x. That's where you need to keep up with this. You get negative x as a term right here. But on the right side, we have 1/7 times 7x. That gives you 1x, correct? So, there you go. Oh, you're talking about 46 is no solution. Thank you. All right. Fair enough. All right. Thank you guys for clarifying that. Because I was about to say, I thought y'all were talking about that previous problem. All right, so you're saying that there's no solution for this problem. Thank you. My goodness. All right, so there you go. I was going crazy on that one. All right, thank you for clarifying that. For number 46 is no solution. All right, well, let me get there, okay? All right, good deal. So I'm going crazy here thinking that y'all talking about the previous problem, okay, because I haven't solved this one yet. All right, so here we go. We have x squared minus x minus 2, right? And then let's go ahead and subtract x squared to both sides. Okay, we end up with negative 2x equals to negative x minus 2. And in order to isolate our variable, let's go ahead and add x to both sides here. All right, so we'll end up with negative 3x equals negative 2. Is that correct? Okay. Yeah. And then you would divide both sides by negative 3. Is x equal to 2/3, guys? Did I do this wrong? Because y'all are freaking me out over here now. All right. Treasure Ghost says there's a much simpler way. Just do x equals to x plus 1. If you divide both sides by x minus 2, yeah, you could have divided both sides by x minus 2. Or you could have said x equals to x plus 1. That's true. All right, and that's how you got that there? Well, then I made a mistake somewhere then. Right? Let's see. Because I got 2/3. Did I make a mistake, guys? Let's see what happens. We have x times x minus 2. We have x minus 2 times x plus 1. We had to multiply that out. We got x squared minus 2x. That's right. You got x squared. This is going to give you x minus 2x minus 2. That's correct. We bring this down. We have the x squared. This is minus x minus 2. That is correct. We subtract the x squared to both sides, so we bring down the negative 2x, which equals negative x minus 2, which is correct. I added x to oh, there we go. I added x to both sides. That's where I made a mistake, guys. So I did make a mistake on that problem. Sorry. All that back and forth. All right. So this is going to give us negative x equals negative 2, and x cannot equal to 2. Because if you divide both sides by negative 1, you'll have x equals to 2, and x cannot equal to 2 because that will create an undefined situation. Treasure Ghost, you're correct. I was incorrect. So x cannot equal to 2, so therefore you're correct that this is the null set, that this is no solution, guys, as stated by Treasure Ghost and Lewis. All right. So I did make a mistake. All right. But at my defense, y'all had me going back and forth all the time. Drive me crazy. All right, there you go. So I did make a mistake, but we corrected it. Done and done. Okay, good deal. I was incorrect, but we fixed it for the review. All right, there we go, guys. So, Treasure Ghost, you could have solved it that way initially. And I was wrong. It's not 2/3. It's gonna be x. It's gonna be no solution on this because you get 2 as a solution. But it's extraneous. This is what it's called, an extraneous solution. That algebraically it solves for this, but it won't work in the original problem. So this is an extraneous solution. All right. So even though we got 2 as a result, we can't use that in the original equation because it makes the equation undefined. It makes it undefined. All right. Treasure Ghost says, but there is a solution, Mr. The solution is that there is no x that you can put in. Pretty much. There you go. All right. So we're going to call that a fail on Mr. Witt. All right. So let's see if I can make up for it in problem number 47. All right. So the previous problem 46 is no solution, guys. And I made a boo-boo. All right. In the live stream. So if you're ever wondering why Mr. Witt is not doing a calculus final exam review live right now, Exhibit A. Problem number 47. It says solve the equation. Oh, that's what your math teacher said, because there's always a solution. I'm not going to go with that one, Treasure Ghost. No solution means no solution. 47 says solve the equation for x. All right. Thank you, Lewis. I am human today. Treasure Ghost says he's Vulcan, and I believe him. All right. Good deal. Live long and prosper. So here we're going to distribute the 3. I got my arrows popping. Let's see if Mr. Witt can make up for past mistakes. All right. Let's hook this up here, guys. So we end up with the right side being x squared minus 2x minus 6. We're going to set this equal to 0 by subtracting 3x to both sides. And I'm going to go ahead and subtract 6 to both sides at the same time. I'm feeling dangerous now. So we'll bring down this x squared minus 5x minus 12 equals 0. All right. And so, to err is human. All right, we shall see. Did I make a mistake here? Because it's possible. All right. So, I distributed first. We have 3x plus 6 equals x squared minus 2x minus 6. From there, we subtracted 3x to both sides. That gives us negative 5x. We also subtracted 6 to both sides. We got negative 12. And this equation is not factorable. So let's use the quadratic formula in order to solve it, guys. So we'll say that our a value is 1. B value is negative 5. C value is negative 12. And we'll use the quadratic equation in order to solve this problem. All right. So therefore, I'll be using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in those values and solve for our equation here. So we'll have negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 12 all over 2 times 1. This gives us 5 plus or minus the square root of 25 plus 48 divided by 2. From here, we're able to say that we have 5 plus or minus the square root of, let's see, 25 plus 48. What's that, guys? I don't know. 25 plus 48. 13, carry that. That's 73, right? All over 2. Yeah, there we go. And there's my solution. There's my solution. Our two solutions for this problem is going to be 5 plus or minus the square root of 73 divided by 2. There you go. There you go. That's the answer. You could expand this result by writing it separately as 5 minus the square root of 73 divided by 2 and 5 plus the square root of 73 divided by 2. But because our quadratic equation is not factorable, you'll end up with this exact answer here. And Lewis is coming down the pipe with his approximations. Amen, amen. All right. So there we go, guys. There we go. That was problem number 47. We used the square root. We used the quadratic equation to solve that one because it wasn't factorable. You could also use completing the square, but because that middle term is so ugly, I decided to go that route. I didn't want to complete the square with that odd number. Enzo says, so accurate is Lewis. That's right. Lewis plays no games today. Good stuff. We have problem number 48, guys. Problem number 48. We have to solve the inequality and graph the solution. We have 2 plus x divided by 15 is less than negative 1. We're going to start out by multiplying both sides by 15. That'll get rid of that fraction, that ugly fraction. So multiplying both sides by 15, let's see what happens here. Get rid of this 15 in the denominator. That'll cancel out. We'll have 2 plus x is less than negative 15. There we go. Then subtracting 2 to both sides. Treasure Ghost, I think I got you on this one. We have x is less than negative 17. What you know about that, Treasure Ghost? So on a number line, guys, you'll do the following. You will have negative 17 on the number line, and you will use an open circle and shade to the left. There you go. Algebra 1 with the open and closed circles. Remember that if you have a less than or greater than symbol, you'll use an open circle. If you have a less than or equal to or greater than or equal to symbol, you'll use a closed circle in Algebra 1. Amen, amen. All right. TG, where you at, man? Did I do it right this time? We have a solution of x is less than negative 17, and we also have a solution of our graph. There we go. Done and done. All right. Appreciate that, Lewis. Lewis, go ahead. Give me a thumbs up on that one. Appreciate that. Rating on Treasure goes to cosign. All right. Ladies and gentlemen, just a reminder that you can get Mr. Witt, me, live in a one-on-one tutorial session. You can check out our website, tutoringmath.net, so that you can get your own personalized private tutorial with me, Mr. Witt. So check out that tutoringmath.net website. Check out the online tutorials. We can use FaceTime or Skype to get that one-on-one tutorial on and popping. That's right. But of course, you can always come through to our Forbidden Tutoring YouTube channel to get free math tutorials from Forbidden Tutoring. That's what's up. All right. Oh, I understand, Treasure Ghost. I'm doing about 5 things simultaneously. I understand how it is. All right. So let's move on, guys. We have problem number 49 in the house. We have problem number 49 in the house. Peggy says she might do that with the one-on-one tutorials with Mr. Witt. That'd be great, Peggy. Check that out. It is very affordable. We have problem number 49. It says to solve the inequality and graph the solution. So here we have x divided by 2 is less than 0, or 7 plus x is greater than or equal to 12. So in a situation like this, class, ladies and gentlemen, you see I'm used to being in that classroom, right? We're going to go ahead and multiply both sides by 2. So it's going to be 2 times x divided by 2 is less than 2 times 0. So solving for this inequality, our 2's will cancel out, and x is less than 0. Good stuff. Or if we were to subtract 7 in the second inequality, we'll find that x is greater than or equal to 5 as well. So we will say that x is less than 0 or x is greater than or equal to 5. And then, of course, we want to put this on a number line in order to graph it. All right. So here's our solution. X is less than 0 or x is greater than or equal to 5. And on our number line, it's going to look like this. Let's check this out. Get this on and popping. Kaylee says, I feel like we're in class, which is the best part. Absolutely, Kaylee. I'm trying to give you that classroom feel, right? With me right there with you, solving these math problems, making mistakes and correcting them together as a group. That's right, Ann. So here, we'll need the two values on the number line. You'll have 0 and 5. All right? And I'll even let Peggy steal some of my style if she wants. There you go. So we have x is less than 0. We're going to use an open circle here, and we're going to shade to the left. That's right. That's why I like putting the variable on the left side when I'm dealing with inequalities, guys, because the direction of the symbol also will tell you which way to shade on the graph. So if you always solve for your variable on the left-hand side when you're graphing the inequality, you can go ahead and shade in the same direction as the symbol. Peggy says she's definitely going to steal some of my style. All right, so be it. So be it, Peggy. All right. Good stuff. Hopefully that helps you out. Good stuff. Then the second inequality is x is greater than or equal to 5. So that means we'll need a closed circle at 5, and we will be shading to the right. Once again, another benefit of having our variable on the left side of the inequality is that the direction of the inequality symbol will point in the direction that you need to shade. Amen, amen. Good stuff. That's the graph, guys. That is the graph. And I will be red boxing it. That's right. Red boxing that graph. So there we go. That was problem number 49, guys. Problem number 49 in a red box. That's right. We're on to problem number 50, though. What you know about that 50? Lewis says, just like last week. All right. That's right. Just keeping it moving. Keeping it rolling. Keeping it rolling, guys. Here we have problem number 50 with a compound inequality. With a compound inequality. Let's see what this looks like. Solve the inequality and graph the solution. What you want to do is you want to isolate the variable in the middle portion of your compound inequality here. I like to label this as the left part, the middle part, the right part. And what we do is we solve for the variable in the middle, but whatever you do to the middle must be done to the left and right portions of the compound inequality. All right. So whatever I do to isolate the variable in the middle portion of the compound inequality, I must also do that to the left portion and the right portion of this compound inequality. I'm going to go ahead and get a little orange juice in me real quick, and we'll get this started. All right, here we go. Let's start by isolating the variable by subtracting 5 to each portion of the compound inequality. So because I need to subtract 5 to isolate the variable in the middle section of the compound inequality, I need to also do that to the left and the right portion as well. So we end up with 7 minus 5 gives me 2, which is less than x, which is less than or equal to 9. Yeah. And so, Lewis, I love your interval notation. Looking good there, looking good. So on a number line here, guys, we will have 2 and 9. And this will also state, because you can write this as an intersection of inequalities. You can state that this is going to be x is greater than 2 and x is less than or equal to 9. Is the way this compound inequality can be expanded. So knowing that, we'll have an open circle at 2. We'll start shading toward the 9. And as we get closer to 9, we'll be representing that with a closed circle. So it'll be trapped in between these two values here as we represent our solution to the inequality. And Lewis is absolutely correct. If you were to write this, guys, as interval notation, it would be parentheses 2 to 9 with a bracket. Yeah, Lewis is showing off today. So all of these are correct as far as the solution is concerned. You could write your answer as a simplified compound inequality. They definitely wanted the graph, so we have this. We could write it this way. Expanded, all right. And of course, this is our interval notation that Lewis blessed us with. Good job, Lewis. Lewis is in the house. Fantastic. Problem number 50, done and done. Let's move on, guys. We have problem number 51. Problem number 51. It says to graph. It says to graph the linear equation. Graph the linear equation. Why is this crooked? There we go. Okay, let's hook this up here. Let's get this looking right. Why is it looking all funky? I don't like the way they look. I don't like the way they look at all. All right, we're gonna get it right. We're gonna get my life right. There we go. All right. So that being the case, we have to graph the linear equation using a table. So they're referring to an XY chart, guys. That's what they're doing. They're just referring to an XY chart. So we're gonna hook them up with an XY chart. That's exactly what we're gonna do. And I'm gonna pay attention to the fact that even though my Y value is solved for, I'm looking at a fraction multiplying on this variable X. So the way you hack this problem, okay, the way you get around being stressed out with this problem is use multiples of the denominator. Use multiples of the denominator. For instance, I'm going to use values like -2, 0, 2, 4 as an example in order to generate my table. Okay, so that's what I'll be doing. Then plugging these values in, if I were to plug in the -2 here, I would end up with -3/2 times 2, right? Well, the 2's will cancel out and leave me a result of -3. So that's what we'll be doing for each value that I came up with. And mind you, I made these values of X up because my domain is -infinity to +infinity. There's nothing restricting me from plugging in any number I want to in this equation. However, I benefit from the fact of recognizing that I'll be eventually divided by 2. So using multiples of the denominator is always a good way to make sure that I don't have to end up graphing a fraction, which is what I don't want to do. So next in line, I'll be plugging in 0, and -3/2 times 0 is 0. So that'll be my next point I can graph. Then plugging in +2. Hey, we plugged a man, making a mistake already, guys. I plugged in +2 right here. So that means that 2 has a Y value of -3. If I were to plug in -2, which is what I was attempting to do at first, let's see what this looks like. I need to slow down, guys. We have -3/2 times -2. So a negative times a negative is a positive. The 2's cancel out. They'll give us a +3 as a result. So now we have this corrected. Good stuff. All right. Then we have plugging in 4. What happens? We have -3/2 times 4. 2 goes into 4 twice. -3 times 2 gives you -6. So these are 4 points that we'll find on the line. And now graphing these points, let's see what happens here. I'm going to go ahead and plot my points in red. The first point will be at -2, 3. So -2, 3 is going to give me a point right here. All right, let's go ahead and move that up to its proper position. There we go, -2, 3. And then our next point is at 0, 0. It's at the origin. We'll have another point at 2, -3. All right, and we also have a point at 4, -6. So that gives us a point right there. Okay, so everything is lined up now. So, as Lewis was saying, it starts out in quadrant 2 and goes to quadrant 4, and that is correct. And we have arrows on both ends, and this is the graph of our linear equation using a table. There you go. So keep in mind, guys, that because we didn't have any domain restrictions, there was nothing preventing us from plugging in any number we wanted to. then we could come up with any numbers we wanted to plug into the equation. But I chose multiples of 2. I chose multiples of 2 because of our denominator. I didn't want to have to end up graphing a fraction. So I got around that by using the multiples of 2 as my values of x. All right. Good stuff. Treasure Ghost says this is the best straight line made without a ruler. Thank you very much, Treasure Ghost. I was trying. I tried to do my best there on that one. It came through on that one. Good thing it wasn't a brace, because I would have jacked it up. But yeah, that was pretty straight. Good deal. So we have problem number 51 done and done. Every once in a while, Treasure Ghost, I get to show my skills, man. Every once in a while. So we have problem number 52, guys. This one, what's next? With number 52, it says to solve. We have x squared minus 7x minus 8 equals 0, and they want us to solve the equation by factoring. So if we have our x squared minus 7x minus 8 equals 0, looking at factors of 8, guys, which is 1 times 8. Let's go ahead and hook this up better. 1 times 8, 2 times 4. We're looking for 2 factors of 8 that will subtract to give us 7. So those 2 factors would be 8 and 1. So I'll open up 2 sets of parentheses here. We'll have our variable x. We'll have 8. We'll have 1. The 8 needs to be negative. The 1 needs to be positive. And then, because we have both factors set equal to 0, we can use the 0 factor property and set each factor equal to 0 separately and solve for x. So we have a couple of videos on using the 0 factor property, guys. In fact, I believe I did one live. There was a live video on using the 0 factor property. So check that out if you haven't seen it already. So we end up with our 2 values, our 2 solutions for problem number 52. And that's going to be -1 and 8 in a red box. There you go. That's problem number 52. Done and done. Let's move on to the next problem. Moving on to the next problem. We have problem number 53. All right, we have problem number 53. Lewis has -1 and 8 as solutions. All right, good stuff. Good stuff, Lewis. Next time, put your answers in braces as a solution set. You don't want it looking like a point, and you definitely don't want it looking like interval notation. So you got some braces on your keyboard there, Lewis. So you say x equals bracket, brace, -1 comma 8 close brace, as far as the correct notation for that, sir. We have problem number 53. We want to factor this difference of squares, so we can do so by doing the following. You simply take the square root of the first term, which is x. You take the square root of the last term, which is 4. And I like to lead with a positive, then a negative, because I'm an optimist. That's right. Kaylee has the answer. Very good. Very good. Very good. Very good. Enzo is correct with his previous answer. Good job. And we are done, Kaylee. That's right. We're going to red box this, Kaylee. Kaylee was on top of that problem, y'all. Y'all weren't even ready. Y'all didn't even see Kaylee coming. She came in like a ninja in the middle of the night. Kaylee's on that Optimus team. That's right. Optimus Prime. More than meets the eye. Y'all know nothing about them Transformers. Y'all better stop. All right, so here we got problem number 53. Let's go ahead and move on. Y'all wasn't ready for. We have problem number 54. We're going to be factoring x squared minus 6x minus 16, guys. We are factoring a quadratic trinomial. That's right. Lewis with the red boxed. That is correct. TG says, wait, what? We ain't waiting. What we get wait on, TG? Hey, guys, we're going to factor this trinomial. We're going to look at the factors of 16. We got 1 times 16. You got 2 times 8. You got 4 times 4. We're looking for 2 factors of 16 that will subtract to give me 6. That's got to be the 2 and the 8. What you think? What you think? Y'all ready for this factoring? Are y'all ready for the factoring? You'll have your variable x. You'll also have 8 and 2. And the sign of the middle term must be negative. And because we're subtracting to get the 6, the 2 has to be positive. It's over. It's over. Come on, y'all. Come on, y'all. We're just getting ready for that final exam for Algebra 1. That's all we're doing. Killing these problems. Leaving them dead. That's what we're doing. We moving on. And as a reminder, let's have you guys subscribe to Fort Benton Tutoring, please. As a reminder, share the stream with your friends and family. There you go. Good job, Lewis, with that correct answer. And also, if you're able to donate, please donate, as that helps us create more free math tutorials with me, Mr. Witt, and Fort Benton Tutoring. Amen, amen. Let's keep it going, guys. Good stuff. We have problem number 55. We have problem 55 in the house. They are giving us a formula. A equals 1/2 the quantity of B plus C times H, and they want us to solve for C. The first thing I suggest us do, guys, is multiply both sides of the equation by 2. If we multiply both sides of the equation by 2, we can eliminate. We can eliminate that fraction on the right side. So I'll be able to bring down 2A equals, these 2's will cancel out, and this just will be just the quantity of B plus C times H, right? So the next thing I want to do is, I think I'm going to go ahead and I'm gonna do this. I'm gonna do this. I'm gonna go ahead and just divide both sides by H. That's what I'm gonna do. The H's cancel out on the right side, so I have 2A divided by H equals to B plus C. And then to solve for the C variable. In order to solve for the C variable, we're going to be subtracting B to both sides of the equal sign. That is what's going to happen. So we have C equals 2A divided by H minus B, and done. That is what we have for problem number 55, isolating that variable C. I'm going to, of course, red box it just like that. An has the answer for the previous problem. Good job, sir. And 55 is in a red box. Yes, it is. Let's move on to problem number 56. All right, we only have 4 more problems after this, guys, so we're going to close out with 60 problems in total for the final exam review. Not bad at all. So let's look at what we got for problem number 56. It says the ratio of boys to girls in the class is 2-3. If there are 18 girls in the class, how many boys are there? All right, well, let's check that out. We already know we have a ratio of 2-3. And so we have boys on top and girls on the bottom. All right, there we go as far as the ratio is concerned. And then, since we have this set up with boys on top and girls on the bottom, when they refer to the 18 girls being in the class, we're going to have our 18 in the denominator of our equivalent fraction on the right side. Boys to girls is 2-3. Oh yeah, so yeah, you're not in Europe then. I guess not. It's the other way around out there, TG. Sorry about that. Here in Texas, it's about that ratio. Good deal. So here's the deal, guys. We want to solve for the number of boys in that situation. So what we could do is we could solve the problem several ways. We could use the extremes means method, aka we could cross multiply by getting our arrows popping, finding out that 18 times 2 is 36. 3 times x is 3x, and then we would divide both sides by 3, and we would have our variable x being equal to 12 in that scenario. We could do that. We could red box it, realizing that the answer is 12, or we could do the following. We could also set it up as 2-3. Let me go ahead and get my ink. Let me get my ink back to black. We could say we have a ratio of 2-3. We have our 18 in the denominator, and we could show that the 3 was multiplied 6 times to get 18. So therefore, 2 times 6 gives you 12 for x. So that's another way to do that problem. All right, so you could use the extremes means method, or you could just identify the fact that they multiplied the original denominator by 6 and use an equivalent fraction to solve for the variable x. Amen, amen. Good job, Ann. You got that answer correct, Ayan. All right, so is it Ann or is it a yawn? All right, so either way, you got it right. Good deal. Good deal. Lewis says 2 times 18 divided by 3. Absolutely. We have problem number 57 with use the zero product property to solve the equation, guys. Oh, yeah. But what you should know is that in order to use a zero product property, you got to have the equation set equal to 0. And currently it is not set equal to 0, guys. So what you want to do is you want to multiply out the left side and then set the equation equal to 0. Good deal. So I got my arrows popping in this problem right here. So multiplying this out, guys, you'll have x times x, that gives you x squared. X times negative 2 is negative 2x. 3 times x is 3x. 3 times negative 2 is negative 6, and this is set equal to 14. There you go. What's going on? Swag Wave. Your favorite teacher is doing just great, Swag Wave. I'm doing just fine here. Let me go ahead and show you some love and put you on point. There you go. There you go. You on the screen there, Swag Wave in the house. I do need some more subs. Go get me some. Go hook me up, Swag. All right, so we're going to combine our like terms here. We have x squared plus x minus 6 equals 14, setting this equal to 0. We'll be subtracting 14 to both sides. We'll have x squared plus x minus 20 equals 0. From here, guys, we can factor, looking for two factors of 20 that will subtract to give you 1 will be 5 and 4. Therefore, you could factor this out to be x plus 5 times x minus 4, and then set each factor equal to 0 and solve for it. That's exactly what we could do here. Amen, amen. So when I subtract 5 to both sides, I'll end up with my solution here. I'll be adding 4 to both sides, ending up with my solution there. Let me go ahead and move this out the way here real quick. Okay. And you end up with x equals negative 5, or you'll have x equals to 4. So as a solution set, see if we get that brace in there. You'll get negative 5 and 4 as your solution to this problem. Oh my goodness. All right, there we go. We're going to hook that up. Had the computer freaking out on me real quick for a second now. No. Fix it. There we go. We're going to pretend those are braces, guys. That's what we're going to do. All right. Swag Wave was in 6th grade, and I do 8th grade math because of you. Oh, that is awesome, Swag Wave. Good job. Good job, man. Well, you'll be able to do more than that. You keep watching. You'll be able to do more than that if you keep watching. All right. Anybody co-signing on those correct answers there? I got negative 5 and 4. Negative 5 and 4 on those correct answers. Peggy, you have a good one. Take care. Magnetar says, what program are you using? I'm using Pen Ultimate by Evernote. Pen Ultimate by Evernote. That's problem number 57, guys. Done and done. All right. We got a few more. We got problem number 58, guys. We're going to 60, and then we're going to call it a day. In order to simplify the quotient, square root of 15 divided by the square root of 2, you'll be multiplying the numerator and the denominator by the square root of 2 in order to rationalize the denominator. We want to get that radical out of the denominator. Thank you, Lewis. So, that being the case, you'll end up, well, that's okay, Swag Wave. We only did 30 problems today. The first 30 problems we did on Thursday. So you can check out part 1 of this review. All right, so multiplying straight across, you'll have the square root of 30 divided by 2. Magnetar, also, you should know that that program is only for the iPad, I believe. It's only for the iPad, but they may have an Android version by now. So by multiplying the numerator and the denominator by the square root of 2, you're able to rationalize that denominator. In other words, get rid of that square root sign in the denominator, and you'll end up with the square root of 30 divided by 2 and done. That's it. It's over. That's it. I mean, if I wanted to show an in-between step here, guys, you would see that we have the square root of 30 divided by the square root of 4, and then taking the square root of 4, you'll end up with 2 in the denominator. And that's how we ended up with that answer. Thanks a lot, Lewis, going ahead and co-signing for me. So we're on now, guys, to problem number 59. That's right. All right. Get your arrows popping should be a meme, says Swag Wave. What's going on, Victor? You're welcome. My pleasure. My pleasure. Victor AI is in the house, guys. Well, Swag Wave, it is a t-shirt, so you can check out that link in the description box and get your arrows popping t-shirt. It's pretty cool. So check that out on our t-shirt shop. There's a link in the description box. All right, so check that out. So here, guys, we want to go ahead and simplify this expression, and we can do so by distributing the negative in front of that second set of parentheses, and we are going, oh yeah, here, I'll go ahead and send you the link. Yeah, let me go ahead and send you this link here for Swag Wave so you can check out what that t-shirt looks like. Let me go ahead and hook you up real quick here, Swag Wave, with the link. It's going to be Fort Bend Tutoring, if I can type here, fortbendtutoring.spreadshirt.com. There you go, there you go. Boom. So check out that link right there. All right, good deal. Just trying to help. All right, Sasha says, will questions like this be on the SAT? Yes, they can have questions like this on the SAT, Sasha. Absolutely. They will start off with problems like this and get much harder, but they can and will have questions like this on the SAT. All right, so we're going to start out by dropping the parentheses here. We'll have 5x plus 7y. This is going to be negative 3y. Plus 9x plus 7y. All right, let's fix that 7y because it's ugly. There you go. Plus 2. So notice that I multiplied all the terms within that second set of parentheses times negative 1. All right. And once we did that, we can now go about the business of combining our like terms. Lewis already has his answer simplified. So I end up combining my x terms together with 5x plus 9x to give me 14x. Then combining my y terms together. All right, let's see what happens with that. 7 minus 3 gives me 4y, and then 4y plus 7y gives me 11y. And then I have plus 2 to follow up with that. And there we have our solution, 14x plus 11y plus 2. And I hate that 11. I'm going to fix it. I hate the 11. The 11 sucked. All right, so we're going to fix that sucky 11. There we go with a better 11. That's what's up. All right. Swag Wave says, I remember the 2012 videos, laughing out loud. I've been here since November 2015. Awesome. That is awesome. And also, Swag Wave says, I agree with the fidget spinner video. Absolutely. You got to get that fidget spinner spinning there, Swag Wave. Appreciate that. Good stuff. Yeah, try to show the students some love for those of you guys that need to have some fidget spinner to help you focus in class. I have no problem with that. Here, guys, is our last problem that deals with the vertical line test. The vertical line test is a way to determine quickly if your graph is a function. That's right. Get your spinners popping is what Swag Wave said. That's a good one. Swag Wave says that his dad loves my videos. I appreciate that. Tell your dad I said hello, Swag Wave. I appreciate that. Does the relation is what we want to say here, guys. Let's go ahead and fix these instructions real quick. Let's fix these instructions here. Let's get this on and popping here. Let's get the blue ink. Let's fix this up for the last problem. We want to go out with a bang. It says, does the relation represent a function? You can tell whether or not this graph, guys, we can tell whether the graph is a function by using something called the vertical line test. And it says that as long as you can draw a vertical line and it only hits the graph one time, then you are dealing with a function. So I know for instance that if I drew a vertical line here, that I would only hit that graph one time. However, if I draw this vertical line anywhere else in this graph, I'm going to hit the graph more than once, right? So if this vertical line, if any vertical line anywhere on the graph hits the graph more than once, then that means that you do not have a function. So does the relation represent a function? This answer is a big fat no, ladies and gentlemen. It is a big fat no. So that's how you use the vertical line test. Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring. Swag Wave says, I've never had a problem like this before. How do you do this? All you got to do is draw vertical lines on the graph. And if your vertical line hits the graph more than one time, that means you do not have a function, Swag Wave. So having a function being able to determine a function by looking at a graph is an important skill to have in mathematics. So the way you can do that is just by doing a vertical line anywhere on the graph, and if you hit it more than one time, you do not have a function. Kaylee says, awesome. All right, Swagwave says, okay, thanks. My pleasure, Swagwave. And I want to let you guys know that I really appreciated you joining us, especially Kaylee, Lewis, Angry Herman, and the rest of the moderators that we had in the house, as well as everybody else that chimed in. Don't forget to subscribe to Fort Bend Tutoring. Kaylee says, thank you, Mr. Witt, for your dedication. Have a great week. And I will do it, and you do it as well. Kaylee, have a good one, and you guys take care. As always, please rate, comment, and subscribe, and if you're able, please donate, as that helps us bring you more free content from Fort Bend Tutoring and me, Mr. Witt. Magnetal says, thanks for the refresher, if I can say it right. I can't even talk right now. Lewis says, show a sine wave. A sine wave in the house. There you go. Got that sine wave going. And then Treasure Ghost says, thank you, Mr. Witt. See you. You guys take care. I appreciate all that you do. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. We appreciate you hanging out with Fort Bend Tutoring.